ECE 111, Lecture 1 Introduction. We'll be going through some introductory material for the Advanced Logic Design Programming course. The overview for this course is we want to learn how to design digital circuits using the hardware description language, and this will allow us to make designs that are way more scalable than what we could do just with using hands. Because the tools can help us to simulate way larger designs that we could do manually, but also they could help us to design circuits and implement them in either custom design logic or in programmable logic such as FPGAs. They also allow us to optimize things using the CAD tools that have been developed in the past 40, 50 years. So there's a lot of great science that goes behind optimizing and designing these circuits. The name System Verilog is a variation of Verilog. It's not a new programming language, but it adds a number of enhancements that makes the life for the designers easier as they use these tools. The System Verilog codes have a .sv extension. The Verilog codes have .v extension. All System Verilog compilers should be able to compile the .v files. It's just that the enhancements that are available for the System Verilog are only compilable in the SV extension code. What we will learn is we will learn a model style to write these circuits in the HDL language that can help you go become a part of a big team that designs these circuits. So we want to also be able to verify and test these circuits. So we will be learning about modules that go around testing these example circuits. We'll be talking about how you could optimize the circuits, and when we talk about optimization in the class, we really mean we want to make these circuits as fast as possible, and we want to make them area efficient, or we want to do a combination of both. We may have this as a constraint or a goal for the design. The tools that we will be using will help us to use simulator, and the simulator we're using is Model Sim, which is the standard in the industry. You could use it not just with the programmable board that we are having here, but for many other simulation environments that use System Verilog. We'll be using the debugging tool Novus Verdi, and we will learn how to use the programmable chip design tools using the Intel Altera Quartus tools, but this is easily transferable to any other set of tool chains that are programming programmable hardware. I try to make my course so that you don't need to really buy a book. We make the slides comprehensive, and hopefully these videos will help you understand the parts that may be missing if you just looked at the vanilla slides. But there are 2 books that are recommended if you want to have a book as a reference. Some people like to have that. The Digital Design and Computer Architecture by Harris and Harris. You probably have used that in your logic design course. The chapters we will be using in this course are chapter 3 and 4. There are multiple editions of this book. The one that has the best overview that is most relevant to this course is the ARM edition, but also the second edition of the book by Harris and Harris is similar to that. So if you have that one, there's no need to try to get the other one. Another book that is recommended by a lot of people in industry who are using System Verilog is the one by Stuart Sutherland, which is going through synthesis and simulation with System Verilog for both ASIC and FPGA. This is a project-based class. There are also web resources that you could use. We will be talking about the specific examples and projects, and you're really expected to do the projects, otherwise you would never learn how to code hardware. This is not something that we could just cover in the lectures. The software we'll be using is the Intel Cortex Prime. You could download it in the link shown on the slide. The software is also available on the servers, UCSC servers. We'll be posting the details on Piazza, how you could use that. If you have a Mac machine, you wouldn't be able to synthesize this on your machine, so you should be able to log into the servers and use it. The family of the FPGA we're targeting in this class is the Intel Altera Aria 2 GX, and you will be looking into software download and basic tutorials on the website. Just before I go forward, I want to tell you something about the way I'm doing the lectures. I try to interleave them with some Blackboard time, but as you know from your experience, the slides are great because I can have a reminder about the course material, and it's a good addition to the textbook if you know, it makes the course self-contained, but they could be bad because I sometimes go too fast. So feel free to replay this if you don't understand this. But I want to, I want to make sure that you understand that it is, it is sometimes more useful to just go through the slides yourself as opposed to just going with my pace on the video. Here is a tentative syllabus for the class. This is designed for 1 quarter. This time we have a 9-week quarter. We'll be talking about the system Verilog introduction, programmable logic and combinational logic. We'll be talking about how you will have memory elements added and how you could simulate delay and how you could have sequential circuits. Of course, if you have a circuit, you want to be able to have testing and you want to make it parameterizable so you could reuse parts of the design later on. We'll be talking about our project, which is basically a hash function and Bitcoin hashing in week 6 and 7. Then we'll be talking about optimizing this project, and the final project is in two stages. We'll be talking about how you could make this design much more optimized, and we will have discussions on that. Next, we will have the set 2 for lecture 1, which is motivating why you should take this class and why this is one of the most important classes you will take in your undergraduate program in electrical computer engineering.